Hello students, in this lecture we will talk about the data encryption standard. So the data encryption standard comes under the category of symmetric encryption. In the symmetric encryption, both the sender and the receiver uses the same set of key in order to perform the encryption and the decryption process. So the data encryption standard is a block cipher. So block cipher means we have to divide our plain text into the equal number of blocks, required number of blocks, and in this case if last block will not contain the enough bits, we have to do the padding. Now the second point about the DS encryption standard, data encryption standard, is it contains fiscal structure. So in the fiscal structure, what is the fiscal structure? Basically the fiscal structure carry both the invertible and the non-invertible components, and again the fiscal structure used to divide the plain text block into two equal halves. The first one is called left hand side and the second one is called the right hand side. Now in the case of DS, the plain text of 64 bits, it is mandatory that my plain text should be of 64 bits. The generated cipher text should be 64 bits, and also the used key size for the DS algorithm must be 64 bits. In the DS algorithm there are two types of keys are used that is generated from the key size 64 bits. The first one is called the cipher key having a size of 56 bits, and a second one is called the round key, also called a sub key. The size of the round key or the sub key 48 bits. Both of these keys, that is the cipher key and the round key, is generated from the key size 64 bits. Now from the round key you can understand that DS algorithm uses rounds. So how many number of rounds in the DS? DS uses 16 rounds. So we have to follow the encryption and the decryption process 16 times. So for the encryption we have to follow the algorithm 16 times, at the decryption you have to follow the algorithm 16 times. So DS uses 16 rounds, and each round will need a key that is called a round key of 48 bits. So these are the 5 points behind the DS data encryption standard. So what about the structure of the DES structure? In the structure of DES there are three types. The structure of DES uses three components. The first one is called initial permutation. Second one is called round structure, or sometimes called DES function, and the last one is called final permutation. So here we have to apply the plain text of 64 bits in the initial permutation. After the initial permutation the round structure will be invoked, and after the round structure invocation the final permutation will be performed, and at last the cipher text will be generated. So what is the diagram of the DS algorithm? I will explain. So this is my plain text of 64 bits. Now here is an initial permutation, and there is a round 1, so on round 16. Then there is a final permutation. After the final permutation my cipher text will be generated successfully. This is my cipher text 64 bits. So in this structure this is my first component, that is initial permutation. This one is second component, and this one is called last component. Sorry, not this one. This one is called last component. That is the final permutation. So each round need a round key of 48 bits. From where this 48 bits is generated? There is a need of some key generation algorithm over there. The key generation algorithm takes key having 64 bits as an input, and this 64 bits will be passed over the initial permutation. Sorry, not the initial permutation, that is called permutation choice 1. So from the permutation choice 1, my 64 bits input will automatically converted into the 56 bits, that is called the cipher key. From the cipher key we have to generate a round key. So for the generation of the round key, we have to feed this 56 bit cipher key as an input to the left circular shift. LCS means left circular shift. So from this left circular shift, my output will be 56 bit key, and this 56 bit key will be act as an input for the permutation choice 2. The output of the permutation choice 2 is the round key having the 48 bits. So that is the procedure in order to provide the key for each round, and that is called the key generation algorithm. So what is the procedure behind this key generation algorithm? The first one is called PC1, that is called the permutation choice 1. In the permutation choice 1 we use parity drop operation. The permuted choice 1 uses parity drop operation. So this is very simple. In the parity drop operation, we have to just eliminate only those bit positions which are multiple of 8. So from out of 64 bits, from the 64 bits, we have to eliminate those positions, those position values. We have to eliminate those position values having multiple of 8. So what are the multiple of 8? Multiple of 8 are 8, 16, 24, 32, then 40, 48, 56 and 64. What are the values? 1, 2, 3, 4, 5, 6, 7, 8. So 64 minus 8 equal to 56 bit will be generated from this parity drop operation. The operation is very simple. Just you have to eliminate those position values which are multiple of 8. Means the values at the bit position 8, 16, 24, 32, 40, 48, 56 and 64 will get eliminated, and rest of the values will become the 56 bit cipher key. So that is the operation behind the PC1, that is called the permutation choice 1. After this operation, my 56 bit cipher key will be generated, which will be act as an input for my LCS, that is called left circular shift. So we have to permute the bits at the left hand side and in the circular manner. So after performing the circular shift operation, left shift operation, my 56 bit key will be act as an input for the permutation choice 2. This permutation choice 2 will contain a compression P box. This compression P box is used to reduce the 56 bit value into the 48 bits. After the reduction, my round key having a 48 bits for each round will be provided to each round. So that is the procedure of the key generation algorithm. I think it is very clear to all of the students. So my key generation algorithm is over. And what are the procedures at the DS structure? The first one is initial permutation. The second one is the round structure, that is called the DS function. And the third one is the final permutation. So for the more elaborative term, the first one is initial permutation. So at the initial permutation, just assume, not assume, the 64 bits is represented as a square matrix of 8 into 8, means we have 8 number of rows and 8 number of columns. This is the row and this is column. In this 8 number of rows, 4 rows will contain only those values which are even in nature, and 4 rows will contain only those values which are odd in nature. So for the example, we have to draw our initial permutation table like this one. So please see this carefully, because a lot of numericals have to be asked in the examination over this. So sorry. Okay, so in order to draw the initial permutation, first we have to assume that my 64 bits input plain text have to be situated in the terms of a square matrix having 8 number of rows and 8 number of columns, in which the rows are divided into 4 and 4, means 4 rows have to be represent the even number of values and the 4 have to be represent the odd number of values. Now we have to draw a table. So in order to draw the table, just try to fill out first the even numbers 2, 4, 6 and 8. These 4 rows will act as a even number. So 2, 4, 6, 8. Now start from 10, 12, 16, 18. Now the next one is 20, 22, 24 and 26. Then 28, 30, 32, 34, 36, 38, 40, sorry, one thing I skipped here. Ten, 12, 14 and 16. Then 18, 20, 22 and 24. And then 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46 and 48. Then 50, 52, 54, 56, 58, 60, 62 and 64. Now this is act as a even row position, even numbers. These 4 rows having the even numbers. Now turn for the odd number positions, like start from 1, odd number 3, 5, 7, 9, 11, 13 and 15, 17, 19, 21, 23, 25, 27, 29 and 31, 33, 35, 37 and 39, 41, 43, 45 and 47, 49, 51, 53 and 55, and the last one will be 57, 59, 61 and 63. So this is the table for my initial permutation, in which I have to divide my even number of rows and the even and the odd number of values also in the terms of 4 rows and 4 another rows. So this is the table for my initial permutation. So don't worry, I will give you one example also, the numerical example. Just try to learn how to write a table, because in the exam you have to draw the table by your own self. So this is the way in order to write the initial permutation table. Now the third one, I will explain the second one, that is the DS function, in the latter part. So the third one is called final permutation. So in the final permutation, the logic is very simple. Just you have to write down the numbers from bottom to top, like 1, 2, 3, 4, 5, 6, 7, 8. Then 9, 10, 11, 12, 13, 14, 15 and 16. Then again you start 17, 18, 19, 20, 21, 22, 23 and 24. And the last one is 25, 26, 27, 28, 29, 30, 31 and 32. Then you have to stop at the 32 and start writing from there. Here. So that is 33, 34, 35, 36, 37, 38, 39 and 40. Then 41, 42, 43, 44, 45, 46, 47 and 48. Then 49, 50, 51, 52, 53, 54, 55 and 56. And the last column will be 57, 58, 59, 60, 61, 62, 63 and 64. So this is the way that how to draw the final permutation table. Now the final part, that is called the DES function, means a round structure. So the round structure is because the round is a fistal round. So in the fistal round you have to divide your plain text block into the left hand side as well as right hand side part. After dividing, you have to just put into the input as a non-invertible function, that is fri minus 1 comma k, where k is the round key. And after this, the output from this function will getting XORed with the left hand side value, and these left hand side and the right hand side have to be swapped. After the swapping, it will be act as left hand side and it will be act as right hand side. This swapping is done by the swapper, and the upper part is called mixer. It is non-invertible component. This is called XOR function, and it is also called whitener. So this mixer is a invertible component, swapper is an invertible component, but this function this function fri minus 1 comma k is a non-invertible components. That's why it is called, ds is called Fistol structure. Ds contains Fistol structure because it used non-invertible components also as well as invertible components. So that is the structure regarding the DES function. So for the more elaborative way, I will explain this as a procedure. Like Li minus 1, my 64-bit plain text is divided into two half of the Fistol structure. The first one is called left hand side and the second one is called right hand side, and each having the bits 32-bit. So first thing you have to remember inside the DES function is, in the DES function, the first one, this function contain expansion p box, the second one is called whitener, the third one is called S box, and the fourth one is called straight p box. These are the four components inside the non-invertible function that is called the DES function. So the first one is expansion p box. So in the expansion p box, the 32-bit input will be converted into the 48-bit output. Expansion p box. So why we need this expansion p box? Because we have to elaborate the bits in order to convert it into the 48-bit form. Why we need it? Because in the next procedure we have to perform the XOR function, means whitener function, with the round key. The round key having the 48 bits. Because the round key nature having the 48 bits, we have to expand our 32-bit input into the 48-bit. We have to convert our 30-bit input to the 48 bits, and this round key generated from the key generation algorithm. So from this key of 56-bit, after the parity drop operation, it will be become as a 56 bits key. From this 56-bit key, we have to perform the left shift operation, left circular shift. So first we have to divide it into the 28-bit part. So from this 28-bit part, individually we have to perform the left circular shift. So from this left circular shift, again we have to combine it and perform the compression p box. From this compression p box, 48-bit round key will be generated. So after the whitener, this is the whitener. Whitener means XOR only. The output will be 48-bit. This 48-bit, what was the next term? The next term is S box and then straight box. We have to feed this 48-bit output into the S box. The X box duty is to convert this 48-bit input into the 32-bit. After the conversion, the last thing we have to do, that is P box table, permutation of the bits. This P box table gives you the output of 32-bit, and this output of 32-bit have to be XORed. Just see the last example. The output of this function, the function contains four components: expansion p box, whitener, S box and straight p box. So from the output generated from the straight p box, this one straight p box is the last component, will get XORed with the left hand side value. The same procedure we have to apply there. So last component is the straight P box. So the straight P box output will get XORed with the left hand side value. So after getting the XORed, we have to perform the swapping. So in the terms of swapping, what will we do? The right hand side operation output will be act as a left hand side, means Li, and the the right hand side operation, that is this one. The right hand side operation, that is Ri minus 1 is 32 bits, is getting XORed with the XOR function. So what was the swapper? I confuse over there. That after performing the XOR function, it will become the right hand side. Okay, after performing the XOR operation, it will become the XOR operation, it will become the right hand side Ri, and the direct one from the right hand side will become the left hand side. So this is the operation inside the DES function. This will contain 4 components. The first one is expansion P box, S box, bytedder, and a P box. So this is called the mixture, and this one is called the swapper, and this one is called the key generation algorithm. So how does 32-bit input will be converted into the 48-bit? So that is the functionality over the expansion P box inside the DES. So expansion P box of DES. The expansion P box will convert 32-bit input into the 48-bit output. So into the 48-bit means 8 into 4 and 8 into 6. Here the 8 represent the number of blocks. 8 represent the number of blocks, and this 4 represent the number of bits in each block. So in this case, you have to write, for the 32-bit input there is a 8 blocks, and each having 4 bits. And the last one. And 8 into 6 means the output. This is the input, and for the output there is again the 8 bits, sorry, 8 blocks having 6 bits in each, 1 2 3 4 5 6 and so on. So this one 1 2 3 4 5, 6, 7, 8, and the last one is 32, 31, 30 and 29. So this 32 will be act as a first input for the output, and this one, the first one, is act as a last bit for the output 1, and the remaining will be as it is copied, like 1, 2, 3, 4, 5, 6, 7, 8 and 29, 30, 31 and 32 for the expansion P box. Now this 5 will be getting swapped, interchange. So 5 will be here and 4 will be here. Like this way, all that needs have to be swapped. Now in this case, there will be 28. So how can we draw the table over this? For drawing the table, just now you can see this is directly put it over there. 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31 and 32. Now I already told you that the first input of my output, this is my output now, so the first input of my output, first bit of my output is 32. So situate 32 directly here, and the last bit will be active as a 1. So the last bit is 1 here. Now you can see in this position, this one, this is the copy of the next value. The next value is 5 and it is copy, means this one is 5 and this one is copy from the previous one, and the next value is 9. Now this table is just like this one, so continue with forthcoming values like 17, 21, 25 and 29. Again for the 32, this is 32. What will be the second value? The second value will be 8. The second value will be 4, 8, 12, 16, 20, 24 and 28. So what was that position? 1, 2, 3, 4, 5, 6. 6. Then how many this? 1, 2, 3, 4, 5, 6, 7, 8. And it is 8. So how many entities it is? That is 48. Now it is successfully converted 32 bits to 48 bits by the duplicacy. So this is 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6 and 7. Here 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6 and this is 7. That's why the 7th bit is 4 here. So we have to find where is the 4. The 4 is here, so continue with the remaining elements, that is 4, 8, 12, 16 in order to make the table. Now the another things that like whitener is nothing but just to perform the XOR function, XOR operation between the two values. And what are the S boxes? There are 16 S boxes used for the DS, and whenever a numerical is came into your exam, then the S box table will be provided you. The P box, this is a straight P box, and again there is a separate table for there. So the next turn is to implement one numerical in order to better understand the DES algorithm, and that numerical I will elaborate you in the next video lecture. So thank you.